Hello. Yay. Okay, we're running a little early, so hopefully we'll finish a little early, and then we can get coffee sooner than hoped. Thank you for sticking around in the room. I know we're the last talk before the coffee break, so we will go as fast as we can. We're going to be talking about Cloud Foundry and Cloud Native, so probably continuing some of the themes that you've already heard today, which should hopefully feel good and not repetitive. So, really, the thing that we are talking about is change. Right? We've heard some people talking already today, but the key thing that we want to talk about is change. And change can feel scary, but actually we should be viewing change as an opportunity. I really like this quote from Steve Jobs, where he talks about this is an opportunity for innovation. So whilst change can be scary, it shouldn't be seen like that. Specifically, the change that we're talking about today is the change from Cloud Foundry to other cloud-native technologies. Kubernetes is what we're probably going to be focusing on a lot of, which we've heard quite a bit about today as well. Derik and I have both been in this ecosystem for quite some time. We've seen already today, it's been really nice. Ram just mentioned about the community. We've seen some familiar faces in the room today, even on the flight yesterday. So it's been quite nice to catch up with some people. But what we want to do today is talk about our journey from being in this ecosystem for a long time, share what we've learnt, some of those lessons, and then hopefully they will resonate with some of you, and we can share some stories, and we'd love to hear afterwards kind of the stories that you all have. So like V did this morning, this is our spoiler alert. This is what we're going to be talking about in the next 20 minutes or so. So what we really want to highlight is things like Cloud Foundry, platforms as a service, are good. They have got some really good kind of outcomes that we see, but there are more things that need to happen when we're talking about platform engineering, and we've seen a journey, certainly I've been on a journey in the last 10 years about what good platform engineering looks like. And so there are other things we can do with more other technologies to make our platforms kind of more composable, more extensible, etc. So we'll start with some quick introductions. For those that don't know me, my name is Paula Kennedy. I am the COO and co-founder of a company called Syntasso. We make Kratix, which is an open source project for building platforms, and we're going to show you a quick demo. Derik's going to show you a demo of Kratix in a little while. I was previously at VMware, Pivotal, Cloud Credo. I'm an ambassador for some things, including CNCF. Don't throw things at me. And I also organize a bunch of community events, including Kubernetes days and DevOps days and a bunch of other stuff. I'll let Derik introduce himself.
Yep. I'm Derik, and I'm a software engineer at Syntasso. My CV is much less impressive than Paula's. I worked at VMware as well, at Pivotal. And I'm here to show a little bit about Kratix and how we can make that work together with Cloud Foundry.
So we're going to talk about platform as a service, very specifically Cloud Foundry. We're going to talk about the good, the bad, maybe the ugly, we'll see. So as you saw from our brief introductions, both Derik and I worked at Pivotal previously, then kind of VMware. Most of you probably know VMware was the original home of Cloud Foundry. That's where the original open source project spun out from. Before I joined Pivotal, I actually was in a startup called Cloud Credo back in the day. So I founded that back in 2012. And actually, we were one of the founding members of the Cloud Foundry Foundation. So that tells you how long I've been around. What was the original intention? So we've heard some talks already about this, but platform as a service really was intended to simplify the developer experience. That's what it was originally intended to do. It was to abstract away infrastructure and operations concerns, and it was designed to make life easier for developers. Right? All they had to focus on was the code. It's interesting, if you look at Wikipedia, the very first ever official platform as a service was called Zimkey, launched in 2006. So platform as a service is not new. It has been around a long time, nearly 20 years. Now, we've already heard this haiku today. I feel like there's a lot of themes coming out from today's event, which is great. But this haiku actually came from Onzi Fakuri. Big shout out to Onzi. He used to be the head of R&D at Pivotal for a while. And this was quoted by Sam Ramji, who used to be CEO at Cloud Foundry Foundation. But this is the magic of Cloud Foundry, right? Here is my source code. Run it on the cloud for me. I do not care how. This is the developer experience that we're aiming for with things like Cloud Foundry. Another VMware colleague, James Waters, used to talk a lot about the value line framework. He probably still does, actually. I haven't seen James for a while, so he probably still talks about this. But the value line framework really is just about abstracting away this complexity and allowing developers to focus on the core, the kind of the unique parts of your business. If you are not a platform vendor, then you shouldn't be spending a large amount of your engineering effort building platforms. You should be spending it on developing features for your end customers. So this is kind of the premise of PaaS. This is what's good about Platform as a Service, and specifically Cloud Foundry. Another great aspect is build packs. We've talked about those a bit today. It was interesting in Christian's talk this morning, for those who caught that, where he talked about being able to kind of patch a CVE very quickly. And that's a great aspect of Cloud Foundry, that fleet management aspect, being able to roll out patches very quickly using the build pack capability. It means that developers don't have to do that themselves. The platform team can roll out fixes and patches very quickly, which is great. So with all that goodness, why isn't everybody using Cloud Foundry? And this is definitely a question I have asked myself in the last 10 years. I've been on a journey. But this, for me, I mean, we've heard a few theories already today. This, for me, is one of the, I don't know, maybe it's a bit sarcastic, but this is actually a great quote. It sort of encapsulates some part of why not everybody is using something like Cloud Foundry. And it's really around developers do want to kind of build for themselves. There's a lot of, engineers want to engineer. But when I was working at Pivotal and VMware, there were some other challenges that I heard straight from customers. So we had one customer that I worked with who, big, large bank, who used Cloud Foundry a lot, right? Had a big Cloud Foundry estate, but when talking to them about how to kind of grow adoption, which is one of the things we were focused on, they responded with, well, it's great for 12-factor apps, but I've got a massive other estate of workloads that just don't fit on Cloud Foundry. And so that's true for lots of large organizations, right? We've heard that again today, that people are saying it's complicated out there. People have got legacy, they've got virtual machines, they've got on-prem, they've got all kinds of stacks running all kinds of places. And Cloud Foundry isn't the one platform to rule them all. Another challenge that I heard often working in this ecosystem was around opinions. So if you're buying a platform as a service, if you're buying something off the shelf from one of the vendors, then by default, you're buying those opinions baked into your platform. So we heard V talking about the difference between standardization versus flexibility, and it's definitely, there's not a one-size-fits-all approach. Everybody's got to make their own decisions about what fits for their organization, what's the right level of flexibility. But when you're using a platform as a service kind of off the shelf, a lot of the things are kind of baked in. So we heard a lot when we were Pivotal about how opinionated we were, and that's true. That was intentional, that wasn't accidental. But if those opinions aren't quite right for your organization, how do you break it apart? How do you build in your customization, right? So those are some of the flexibility versus standardization challenges. So, to summarize where we are, kind of the good and the bad, PaaS are great, right? They have a really good goal in mind. I mentioned the value line. One thing we didn't used to talk about when I was at Pivotal was cognitive load. It wasn't a term that got talked about a lot. But more recently, with the publication of Team Topologies, for those who've read that book, there's a lot of focus on reducing cognitive load for developers, and that's where platforms help. Right? They can actually reduce complexity. We focus above the value line. We reduce cognitive load. But it's not a one-size-fits-all solution. Not everything can run on a Cloud Foundry or a PaaS, and it can be hard to customize. So we've talked already a little bit today. We've heard about different opportunities, different solutions like Karifi being one. Derik's going to show you a little bit about what we've been building at Syntasso.
Cool. Hello. Okay, so so let's just talk about what it is that we want to build. Because what I really want is that CF push experience, right? I still remember when I first wrote my first Rails app, and I wanted to deploy it, and I wanted to deploy it with Cloud Foundry. All that I had to do was CF push, and it was magic. It was great. Before that, I was working as a JavaScript developer that had to run and roll JavaScript files with FTP and then pray and see what happens. So that was really good. And we want to provide that same experience in whatever platform we have, right? We basically want to respect and keep on the haiku of like, here's my source code, run in the cloud for me, I do not care how. Because most developers don't. They just want to test their application, run the application, see how it runs, get a URL, off you go. But organizations do care about the how. And I think that's one of, to Paula's points, that's one of the challenges of like, what is the level of customization and flexibility that you want to provide on top of your platform? Because you do care how. You do care about the business rules, you care about your security compliance, you care about firewalls, you care about a lot of stuff. So how can we build the same experience for the user that is the developer, in something like Kubernetes? So in a very simplified diagram, most of you probably know more about the CF than I do. I worked on the cloud controller for a little bit, but not in the rest of the stuff. But basically what happens behind the scenes is you CF push, you hit an API, a build pack is selected based on the code, based on the blob of code that you have, that is compiled into an executable that's put in on the Diego cell and runs. So that's kind of where the magic comes from. So how do we achieve that on Kubernetes? Like, we know how to deploy things on Kubernetes. You write a lot of YAML, you write all of them together, and off you go. But that's not exactly the same experience. You want the developers to focus on the code, focus on what builds like value to the business, and not exactly like writing a YAML together. We've seen a few options on how to do that. I'm here to provide yet another one. So this is the development lifecycle, very simplified. You have the code part. Developers allegedly know how to code. They are there in their basements. They build stuff. They say it's ready. They want something to build that code for them, and then they want to execute the code and run the code. That's really it. So we don't need to change how we don't want to change how developers code, and that's why we want the CF push experience. And we don't want them to care about necessarily how it runs. We want to give them something in the middle to make it possible. So we know that Kubernetes is pretty good at running stuff with like the deployments and the ingress and all of those YAMLs that no one actually knows how to write. And we know the developers can code, so let's build that thing in the middle. So what is the build? The build is basically to run things in Kubernetes and even to run things in Cloud Foundry. It's basically you build a container image, you get that containerized application, and then you generate some objects. In Kubernetes ecosystem, you generate the Kubernetes objects, the service, the deployment, the ingress, the whatever you need, and then you run. And that's where Kratix can help. So Kratix is an open source framework for building platforms on top of Kubernetes. You can build, well, I will show here today the app experience, how to deploy an application on Kubernetes, but you can build much more than that. It's an open framework. You can customize and add anything, provide anything as a service. And the core concept of Kratix is a promise. Unfortunately, it's an overloaded term, but a promise in our case is a promise that your platform engineering team makes to your organization. I promise to provide you this service. And this could be a database. This could be an application, like a way to run applications. It could be any sort of service, the entire development environments on demand. So, and a promise, in a nutshell, it's still Kubernetes, so it's YAML, but it's not a YAML that your developers need to care about. But it's a YAML that you write to define what it is that a user can configure, and that's the API. What do I need to exist beforehand for me to actually provide the service? Like, are you giving slices of a big database? So you need that database to exist. Are you running something that is backed by Corifi or a Kubernetes operator? Then that's like, you need that dependency to be installed. And then the core of it, the magic of it goes in workflows. So workflows are pipelines that you write, a series of container images that execute what needs to happen to deploy that particular service in your organization. Kratix is also multi-cluster, so you can have destination rules. Sometimes you want to run things in different clusters depending on the workload, so you can set that in the destination selectors. But Kratix itself doesn't know how to build anything. Kratix is a framework, so you need something that actually can get the code and transform it into an executable. And for that, we will use Paketo in the demo today. So I don't know if you're probably all familiar with Paketo, but Paketo is an open source project that provides build packs that are production ready for most of the most popular languages. And yeah, the Cloud Foundry apps are built with build packs, so we want to use that. We've seen multiple times here today the benefits of build packs. To run build packs to run Paketo on Kubernetes, to build apps on container images on Kubernetes, you're also going to use Kpack, which is the Kubernetes native container build service that extends Kubernetes, that gives Kubernetes the capabilities of building images and container images. So how does Kpack with Paketo works? It's basically this. So you have a few components in your system. You have a stack. I think we saw a talk this morning about stacks specifically, so that's very useful. Don't need to explain too much. But it provides the build image, the base image for your applications, and also for the build container. You have a store that defines what are the build packs that are available in your cluster to build. So in here, for example, Java, Node.js, from the Paketo build packs. You wire that up in a builder, and then you declare an image. An image is the custom resource that Kpack provides to declare an image. Like I want to build this image from this builder, from that source. And that will kick off a build container that will build the image and push to the registry. Putting it all together, what you're going to do, what I'm going to demonstrate in a second, is a Kratix promise that on request will declare the image, will ask Kpack to build an image using Paketo and build packs, and also generate the right deployment and service and ingress and all the Kubernetes objects. Those components, like all of that definition, is going to be sent over to the Kratix scheduler that will find an appropriate place to run and build that. And hopefully, if everything goes well, we'll have a running app by the end of it. All right, let me give that a go. That is start mirroring. Great. Okay, so let me just make sure that I have everything in here. Here's the, all right. So what do I have in here is a set of clusters. So I have two clusters right now. One is on the top is the platform cluster that is running Kratix. You can see the Kratix running over here. And I also have a worker cluster that is where I'm going to run my workloads. I'm going to build my images. So if I am a developer using this platform, I could come over here and say get promises and see what are the promises available in my particular platform. So this promise is a promise that I built, and it's going to use Kpack and Paketo to deploy my application. A promise has a API, an interface. So this is the API that I'm providing for my organization. So you can see that it has where is my source code, so you can go to that URL and find it. What is the type of it? Maybe you want to provide different ways of building things, from images, from blob stores, from zips. Here's from Git, and then a few other pieces of configuration. Kratix also works really well with Backstage. So here we have the same view that we have over there. I could come over here in UI and actually fill the forms and request my services through the UI if I want, or any other interface. So given it's a framework for platforms, the way that you consume and interact with that platform is up to you. So if I'm a developer, I want to do the same experience as CF push. What I could do is just apply that YAML. So it's my application manifest, so to speak. And what Kratix will do on the back of that is run a series of workflows. So those workflows are the bits that we defined in our promise. And what they're going to do is do the series of steps that we need to run the application and to build the application. So the first thing it's going to do is generate the documents, and it's also going to generate the app, the image request. And you can see in the bottom that already started. So I have my application that is failing to start. Kubernetes is eventually consistent. My image is not yet built, so it's failing for a moment. But you can see that the build pack and the Kpack is already building it. So if I quickly take a look at the containers, we should see the build pack stages going through, right? We have the analyze to detect what is the build pack that I need to use, the detect, and then the build itself. And if we look closely to it, we can see that Paketo, we're using the Paketo Go build pack to build this Go application. Sorry about the contrast. Just going through the steps to build the container image. So you can see that it's running the Go build and et cetera, et cetera. So in a number of minutes, this image will be built. It's a relatively small application, so it should complete quite quickly. And then my application is going to run. So I have, so we don't have to wait, build another application already that is already available in our organization that is using the Python build pack, going through the exact same process. And at this point, the user can come over here. They have the URL. They can click on it. They can see the application running, and then they can continue developing it. So they didn't have to worry about generating any particular Kubernetes documents or how to build the image or anything. They can focus on the code, and they can get the application running. What Kratix did behind the scenes was to generate a series of documents. You can see there's loads of them in here, but including the deployment, the ingress, the service, and any other things that you have defined. In my promise itself, and if I open my promise, you can see the series of steps that I codified. So I have a step that says, okay, build me, declare me an image. I have a step that says deploy me an app, and I can easily extend that. I can easily add more steps that are defined by your organization. So let's take a look at what that could look like. So hopefully at this point, my build is finished. Unfortunately, not unfortunately, it's just a matter of it. I don't want to wait all of the back off policy, so I'm just going to kill this pod right quickly. And the pod is going to come back up, and you can see that my application is running now. And if I do get applications, I can now access my to-do app. It's up and running. So great. Just to prove that this is actually building an image. Great. So I was just talking about how we can extend it, and we can easily add more stages. So I'm going to apply a different promise here that has one extra stage that is running a security scan. And this is just to illustrate the sort of things that you can do. So in your organization, you may want to instrument your CF push, the equivalent to CF push with more steps, like notifying people, doing security scans, validating licenses on code, or any sort of things like that. So you can easily add those into your promise. And if I apply this promise, what Kratix will do is something interesting. So first it's going to update the promise. So it's running the promise pipeline in here. And then it's going to look around and say, OK, what applications do I have? I need to reconcile them. So you'll soon see for the to-do app and for the Python app, they will start their own pipelines. And they're going to run the security scan on the things that are already running. So your user doesn't have to change anything. You updated your promise. Kratix will roll out those upgrades across the board. If, for example, you want to update a version of a build pack, you could add in the promise, and that upgrade will roll out as well through your fleet of applications. So, and just to show you what is going on in there, we should be able to see our new step, the security scan step, and this is using Trivy to run a security scan. So it's not going to fail the pipeline otherwise, because those are all sample applications that have security vulnerabilities that are patched in 2018. But you should see it complaining about it, and then you can choose what to do with that information. We can send a notification, we can fail the application, we can fail the deploy, we can do any one of those things. Let's see if there is one here that completed, or this one completed. Great. So you can see that it found a few security vulnerabilities in this repo. Here's the report. I could have failed this pipeline. I could have sent an email to, I don't know, Marina from security for her to take a look at it and complain with the developers. But it's up to you. Like, it's your platform. You decide what you do with that piece of information. Great. So this, we showed how to get the similar experience and how to extend it and do customizations. But as I mentioned, Kratix can do more than that. You can also have services or any other sort of anything as a service in your platform. So here I'm going to install a Postgres promise. That promise is available in our marketplace. So we have a marketplace of promises that is in here. So you can see that there's a bunch of ready-to-use promises that you can get and apply to your platform and get those as a service. But that will basically provide you with new capabilities and new capabilities in your platform. I'm not going to request a Postgres because it's a little bit more the same. I'm going to request a Postgres and I'm going to create a Postgres. But the other thing that Kratix allows you to do is to assemble what we call the golden paths or compound promises. So I could build a promise that lives at a higher level and uses the lower level components to build more compelling experiences. So if you think about Heroku and how Heroku deployed Rails apps, you could say, deploy my app, and it would actually create a Postgres database behind the scenes and attach to your Rails app. And that is even more magic than me having to run CF create service. So you could wrap some of those functionalities in those high level promises. And yeah, just to show backstage, Kratix has an integration, so you can see that my application is available here and has some information, including where is it running, and that we found some security vulnerabilities. Great, and I think that's pretty much the demo that I had for today. Let me see, where's the notes? I may have lost it. Oh, yes, let me stop mirroring first. The hardest part is actually getting Google Slides to work properly. Here we go. All right, and I will hand back to Paula.
Thanks, Derik. So, to wrap up, we've seen that Cloud Foundry's got an awesome experience, right? Really one of the strongest features of Cloud Foundry is that developer experience, that abstraction, that increases developer productivity. So Owen was talking about kind of the ROI on the platform, like what are we actually all trying to aim for? What's our holy grail? Our holy grail is to be able to deliver features to our customers as fast as possible, have a faster time to market, have a great kind of return on the investment on the money we're spending on our platforms. And Cloud Foundry delivers that, but not all things fit on Cloud Foundry. And Derik's shown kind of, like I say, our framework we've been building, which you can have a similar CF experience, you can run it alongside, you can kind of integrate with Cloud Foundry, you can also then have lots of extensions and different ways of doing things. And I think what we're interested to learn, I'm talking to people later on today, is what are other people trying to do with all of their workloads, with all of the spread of things that they've got, trying to integrate Kubernetes and Cloud Foundry, trying to run them together. What are the things that you're trying to do? Derik mentioned that we've got a few other things, so we didn't have time to show you all the magic of Kratix, but Kratix does a whole bunch of other stuff as well. So if you're interested to learn more about the open framework and how it works, you can come talk to us. We have things like more fleet management, not just on applications. We have golden paths. Platform democratization is where we talk about other parts of your organization can write promises, as Derik described, and put them into the platform. So what you don't end up with is this massive bottleneck of the platform team having to do everything. It's a way of allowing other teams to contribute into the platform with their own capabilities. And the floating versus syncing, we haven't mentioned AI so far in this talk. So really that's a thing that came from Gregor Hoppe, and he talks about your platform should be, essentially it should be able to float above new technology. So if something new comes up, like AI, your platform needs to be composable, it needs to be able to plug new things in, it can't be brittle and kind of sinking, it needs to be adaptable and floating. And that's one of the things that we try to live by at Syntasso. So that's us. We will not hold up with doing live questions, so if you have any questions for us, please come and chat to us in the coffee break or later at the drinks, and thanks for having us.